right, guys, we're back. Another problem right here. What is the mass of water? Okay, again, we're dealing with water again because sometimes in the question they like to deal with water a lot, right? That requires 16,500 joules of heat energy to change the temperature from 60 degrees to 89 degrees. So you see, you got your container water, the temperature is changing delta T, all right? Now what's happening, the water's gaining a certain amount of energy, the temperature's changing, the temperature's going up, right? So once again, once you establish that you have a temperature change, you're using a delta T equation, the delta T equation on table T, the first one, right? So let's write it again. Now after a time, people, you're gonna become, very adept at using this triangle, right? Q is equal to MC delta T once again, right? But this time, as I always said, right, we're gonna read it slowly. What is the mass? You stop right there, you take a breath. Okay, we are looking for M, we're looking for mass, right? And mass, the unit is grams, yes? Okay, no problem. You continue reading. Now, it requires 16,500 joules. Automatically, when you see joules, what letter is that? Yes, it's gonna be Q. That's our Q value. The mass right here, we don't know. Okay, you continue reading. Okay, now here the temperature changes now from what? From 60 degrees to 89 degrees. That's gonna be our delta T. You make a little note somewhere. Okay, the problem. And from 60 to 89 should be 29 degrees C is our temperature change. Remember, folks, if you go from one initial temperature to final temperature, you don't plug these guys, any of these guys in the equation. You gotta subtract them, okay, to get the difference. That's what the delta sign means, change, difference, right, in temperature. Okay, so don't fall for that mistake. Alrighty, so you go back to the triangle, right, and you realize you don't know the mass. You're looking for mass right here. Put a circle around it, right? So what the triangle is telling you to do in terms of this guy right here is Q, right, over C times delta T. All right, once again, Q over C times delta T. So M, mass, right, is equal to Q over C times delta T, C being specific heat. And you plug your values in. All right, so here we go. Then, Q is here, so that's 16,500 joules. All right, notice I'm using my units, not just magical numbers. All right, we know from experience, we look on the reference table if we can't remember it, for the specific heat of water. Now remember, it's just for water, it's on the specific heat of water, right? Other guys, they eat other substances, they have to give it to you, or you calculate it. But water just so happens to be 4.18, okay, joules over grams degrees C, right? Times the change in temperature, which in this case is 29 degrees C, all right? So you set it up, you're looking for mass. Now in your mind, right, you're saying to yourself, you know what, I'm looking for mass, hopefully these things cancel and leave me with grams, right? So here you go. The joules here and the joules there, they cancel, okay? The degree C here and the degree C there, they cancel. What are you left with? You're left with grams, right? So you're happy, okay? So it's all a matter of now of doing this carefully, this mathematical operation carefully. Now what you simply can do, guys, is have your 16,500 divided by 4.18 and divide again by 29, done. Okay, so that particular answer I got for that is 136.2 grams. Okay, so check it out, do that problem, and see if you got a corresponding answer. Okay, no problem. Alrighty, let's do one more. Okay, now, a container of 625 grams of water, okay, water again, is at an initial temperature of 45 degrees C. Now, out of all the delta T type problems, this one here gives students the most issues, right? And the reason being, they're given an initial temperature and sometimes they ask to find a final temperature, or they're given a final temperature and ask to find an initial temperature, and the confusion starts because sometimes they say, you know what, this 45 degrees, that's my temperature change, I'm gonna use that. That's not your temperature change, folks. That's your initial temperature, your starting temperature, okay? So what I tell everyone to do is this: draw a container, right? Anytime they tell you, right, you have a problem with initial or final temperature, draw a container, have your water in there, okay, your H2O in there, alrighty, and draw a thermometer, all right, okay, and put a mark there on the thermometer, okay, and if it's final temperature, label it final temperature, but in this case, it's initial temperature, so label that 45 degrees C. So now you have a visual of what's going on. You got a certain amount of water, okay, and it's initially at 45 degrees C. Now what's happening? You got 625 grams of water, right? So that's gonna be mass, right? Okay, that's our mass, so we know the mass. Okay, it's initially at 45 degrees, okay? We do not have delta T yet, folks. That's just initially at 45 degrees. They're asking us what's the final temperature gonna be if it gains 20,250 Q of heat energy. Now this 20,250 joules, what letter is that gonna be, guys? Okay, that's going to be our Q, so we know what Q is, our heat energy is. Good, so we know Q, we know M, right? And the funny thing is, since it's water, we know C, because that's on the reference table. Okay, no problem. Now, guys, what's gonna happen is this. This guy right here is gaining energy, absorbing energy, gaining energy, right? So we, from our mastery of this topic, we know that the water's gonna warm up, we know that the temperature is going to change, all right? So the temperature is gonna go up some amount. Right now we don't know, but we know it's gonna go up some amount, right? And guess what, folks? That temperature is gonna change, hint, hint, by delta T, alrighty? So what we have to do now is find delta T, how much the temperature went up. So let's do that. So we have our triangle again, as always, okay? Q is equal to MC delta T. Now on a test or a quiz, folks, you don't have to keep writing this triangle over and over and over again. You can have it in one place on the corner of your test and just go back to it and use it, right? But I'm writing it over for emphasis. All right, so Q is equal to MC delta T, right? We know Q, we know M, we know C, right? We know Q is 20,250. We know mass is 652. We know C for water is on our reference table. We are trying to find this guy right here. How do we find it? Delta T, okay, is equal to what? Q over M times C. Q over M times C, okay? And you plug your values in. All right, so we got Q is 20,250. So I put that on top. Bam, joules, units, over to M, which is 652. Okay, grams, times C specific heat of water, which is 4.18 joules over gram degrees C. Okay, so now what happens? The grams and the grams, they cancel out, right? Okay, grams and the grams, they cancel out, alrighty? The joules and the joules, they also cancel out, all right, guys? So now what are we left with? We now are left with degree C. We're happy since we're looking for temperature, right? The change in temperature. So when we do that, okay, in terms of calculation, I got a delta T of approximately 7 point, okay, so my handwriting's betraying me, 7.75 degrees C, okay? Now once again, I'm not using sig figs, okay? So 7.75 degrees C, or approximately 7.8. Okay, so if you got either of those, you're on the right track for your delta T. But is the problem finished? No, it's not finished, okay? Because the thing is, that's our change in temperature. We initially started at 45 degrees C. So if you're at 45 degrees C and you get warmed up, what do you do with that change in temperature, okay? Do you subtract it? Do you add it? Do you leave it alone? Do you not do anything? Do you multiply it? No, you gotta add it, right? Because that's the additional amount of, represents the initial amount of temperature change that happened due to the increase in heat. So the final answer, right, okay,